All right, Math 1, we are going to wrap up radicals today. I will be going through the book, so if you want to go ahead and get that out on page 344. We'll go through some of these examples, but over here, what we're going to be doing is we are going to start division. All right, and division can look something like this, something like this, something like this, and then there's one more case that I need to put a little more time into. All right, so underneath a radical, you could have both the numerator and the denominator under the radical, and when that is the case, you can go ahead and divide anything like you would normally. So for an example, you can say 2 goes into 50 25 times. You're just dividing as you would any other normal fraction. So 2 into 50 25 times. Then you can say, well, since there's an x in the bottom, it can cancel with one of the x's in the top, so I'm left with an x up on top. And then you have a y on the top, which will divide out with a y on the bottom, and this is what you're left with. And then now you can look and treat it as a radical. And what you're going to say is, what is the square root of 25? Well, it is 5. And then you have this x that's still left under the radical, and that is how you are going to leave your finished answer. All right, when you have something like this that is very, very similar to the one we just did, you can either write it underneath one big radical, or you can separate it under two like that, if that makes you feel better. You know, sometimes I write it one way, or sometimes I write it the other. It doesn't really matter. So we're going to do the same thing. 2 goes into 18 9 times. All right, we have an x squared and an x squared that divide out. We have that y that is still left on the top. So very similar to the last example, the square root of 9 is 3, and then you're left with the y underneath that radical. All right, so finished answer. All right, if you have something like this, you cannot divide the 3 into the 18. The 3 is not underneath a radical. It is what I would consider a whole number, so you cannot divide it into a radical number. Radicals can divide with radicals, wholes with wholes, but you cannot go in between the two. All right, so what I'm going to do is look on the top, and I'm just focusing on simplifying down the radical. 18 divides in, or it breaks down. We did this earlier. It breaks down into 9 times 2. All right, so right now the 9 becomes a 3. All right, that is a 2. Now I'm going to deal with my variables. Remember, we did this last time. Whoops, the 2 is kind of right out here. 2 divides into 2 once, so I get an a that comes out with the 3. 2 can't go into this b, so we're left with the b underneath. All right, and let's not forget we still had that 3 in the denominator. All right, so we have this. Now, since that 9 became a regular whole number 3 on the outside, now this will divide out with that, and what we are left with is a to the square root of 2b. I know that probably seems like a lot, but just take it step by step by step. Don't think you have to go from here to here. That's really confusing. Show your work, write out your steps, just keep going until you cannot go any further. All right, in your book, you can kind of read this box over on page 344 if you want, but what it tells you that a radical expression is simplified if 1, 2, and 3. All right, so there are no more perfect squares in it. The radicand does not contain any fractions. Remember, a radicand is a number underneath a radical. So the number underneath a radical cannot be a fraction. We don't want that. All right, and then down here, no radicals appear in the denominator of a fraction, and we haven't crossed this one yet. We have not done this, and we will today again. All right, so let's just go through. This is where we started the very first day. We just broke down a basic 1 radical here, and you found a perfect number that went into this, which was 36. So you rewrote 72 as 36 times 2. The square root of 36 was 6, and you were left with a radical 2. We were done. All right, this is a perfect number. The square root of 225 is 15. Bam, you're done. Here you break down the 17 into 9 times 13. This is all review. That's why I'm going a little bit fast. This is just going to be 4 times 3 times the square root of 13. Well, that gives you negative 12 square root of 13. All right, so if you get a little better with these, you can kind of go through them a little bit faster, but this is all the stuff we have done so far. All right, then we introduce some letters with this. All right, so again, when we did this, I'm just going to rewrite that negative m for a minute. The square root of 80 will break down into 16 times 5. All right, the 16 becomes a 4. So now I have negative 4m because I brought the 16 and it joined this m outside. I just put it in the front. I was still left with the radical 5. All right, now we did this again last time. So we said 2 goes into 9 4 times evenly. So 4 m's will come out, but there's already an m here. So 4 are going to come out to join the m, which leaves me with a total of 5. But don't we have 1 left over? If 2 went in here 4 times, that's 8, which we have 1 m remaining, and that 1 m that remains, it remains underneath. All right. So here we're going to break this down. 50 is 25 times 2. We've done this enough. The square root of 25 is 5. You're left with radical 2 underneath. Then you're going to say how many times does 2 go into 5 evenly, and that is a twice. And then you have the 1t remaining underneath. All right. So you can go ahead and practice number 4 if you want and see what you get. Okay, I feel like we did this last time too. On the worksheet, you can multiply these out. You can break them down ahead of time. Again, there are a lot of different ways you can do this. So we're going to multiply the radicals together, and that gives me 108. I believe, let's see, that would be, I'm trying to think what goes into 108. 48 now. I don't have my calculator over here to break this down. So let me see, 9. I think it's 9 times 12. That I know, but 12 can go down further. So let's see, 3 and 2 is 6. So 36 goes into 108. So it'd be 36 times 3. Yep, 36 times 3. All right. So we multiplied the 6 and the 18 to get that. I'm going to break down 108 into 36 times 3. Well, the square root of 36 is 6, which then gets multiplied to the 3. So you get 18 square root 3. Here you can multiply it back out, or you can do it, break it down as is. I don't know. I'm going to go ahead and do this a little bit differently. I'm going to make the square root of 9 become a 3 out front, just comes out. I still have the 2a and the a to the third, which I'm going to combine out to get a to the fourth. Well, now I can say, well, I have a 2 here. 2 goes into 4 twice, so I can pull out an a squared, and that's what I'm left with. All right, here again, multiplying, you can multiply your outside numbers is 21. You multiply the inside, I'm going to get 100, x to the 6th. Well, 100 is a perfect number. It is 10, so I'm going to bring the 10 out, and that makes that 210 because I multiply them. And then 2 goes into 6 3 times. I get x to the third, and that doesn't leave any radical at all left over. All right, over on page 347, I'm looking at number 6. This looks complicated, but it's not really too bad. What I would do is multiply these two together first. Negative 1/3 times 6. Negative 6 is 2. Multiply what's underneath your radicals here. Let's see, we're going to have 144. I think 18 times 8 is 144. And then when I combine my c's, I add my exponent, so I get c to the 14th. Well, 144 is a perfect number. It is 12, so 144 comes out as a 12, and the 12 multiplies to the 2 to give me 24. All right, that takes care of that. I have that 2 here. 2 goes into 14 evenly 7 times. I don't have any remaining, so there's my finished answer. All right, you can do word problems with this. You can kind of look those over. It's not bad. I want to really focus on the division down here. All right, starting with this one, I'm over on page 348. So if you need to, you can separate this into 2. You can leave it into 1. It really doesn't matter how you do it. You can take 9 into 144. A lot of different ways you can do this, but I'm going to go ahead and split it up like this because I know they're both perfect numbers. The square root of 144 is 12. The square root of 9 is 3. 12 divided by 3 is 4. That simply comes out to be a 4. If I had divided it in earlier, I would have gotten the square root of 16 because 144 divided by 9 is 16. And then I would have said the square root of 16 is 4. So it does not matter which way you do it. All right, here, 4 goes into 16 9 times, so I get the square root of 9. This a will cancel with 2 on the bottom, so I'm left with an a squared on the bottom. That a cancels with one of the a's, leaving with an a squared. Well, the square root of 9 is 3. The square root of a squared is simply a. Remember, we're dividing the 2 into the 2 one time. We're done. The radicals are all gone. All right, here, you're going to take the square root of 25 is 5. Remember, we have a 2 here. 2 goes into 3 one time, so 1y comes out. But since it's a 3, we have 1 remaining. Then I come down here. Well, z squared, the square root of z squared is simply z. Nothing here can simplify down. Those are both your whole numbers. This doesn't have a fraction or anything like that in it, so we are finished. All right, here's where on page 349 we're going to run into a little snag. We have not done this before. It is called rationalizing the denominator. If you remember, our very last rule was we cannot have a radical in the bottom of a fraction. All right, I can't break these down. I can't divide them in. There's nothing more I can do. It looks simplified, but I still have that radical in the bottom. So how you take care of that is you want to multiply this by something that gets you to a perfect number so you can pull it outside of a radical. So basically on square roots, it's usually what's in the bottom. So I'm going to multiply by the square root of 3, square root of 3. All right, remember this is just the number 1. It's a fancy 1. Square root of 3 divided by the square root of 3 is just 1. So I'm multiplying by 1, so it does not change the problem. Up on top, the square root of 2 times the square root of 3 now is the square root of 6. On the bottom, when you multiply two radicals together that are the same, you're going to get 9. But what is the square root of 9? It is simply 3. So after a while, you'll start realizing when you multiply two things that are the same, you just get that number without the radical underneath. All right, so what our goal was just to get rid of the radical in the denominator. So if you want to check it, if you go to your calculator and you take the square root of 2 divided by the square root of 3, hit equal, you're going to get a decimal, but that decimal will be equivalent to the square root of 6 divided by 3. All you've done is simplify it down by rationalizing the denominator, getting rid of the radical in the bottom. All right, so here, a couple ways you can approach this one. I like to simplify down if I can, just because it makes my numbers smaller. All right, so the square root of 5, nothing can happen with that. Don't put a times here, put an equal. So I'm just going to leave the square root of 5. The square root of 18 is really the radical 9 times radical 2, so I get 3, and then the 2 remains, and so does that m. All right, so now what I'm going to do, I have to get, the 3 is fine. I don't mind having a whole number in the bottom, but I cannot keep this radical number. So to get this to something else, I need to multiply by this 2m. So I need to do that here, 2m. Well, the square root of 5 times the square root of 2m is simply the square root of 10m. You multiply 5 times 2 to get the 10, and the m stays. Now, down here, again, I just talked about this. If you are multiplying two radicals that are the same, you simply get what's underneath them as an answer. So it would give you 4m squared, but the square root of 4m squared is really just 2m. All right, so when I multiply this times this, I get 2m, but I still have that 3 there. So I really have 3 times 2m, which then becomes 6m. So finished answer, 10m over 6m. Now kids will usually say, well, can't we divide the 6 into the 10? No, this 6 is a regular whole number 6. This 10 is a radical 10. Radical 10 is not the same as a number 10. It is totally different. It is a number barely over 3. All right. These m's also cannot simplify down. They cannot divide out because this m, again, is under a radical. This one is not. So don't be tempted to get too crazy and start, simplifying down more than you can. There's nothing more you can do here, nothing more you can do here, so you just go on. All right, so here we go. I can't have the radical in the bottom. We've done everything we can, so you're going to multiply by radical 11, radical 11. Up on top, 1 times the square root of 11 is the square root of 11. Down in the bottom, again, when I have two radicals that are the same, I multiply them. I just get the whole number 11. Finished answer. All right, here I'm going to break down the 28. 28 is 4 times 7. All right, so on the top, I can't do anything, so I'm just going to leave that for right now. All right, on the bottom, 28 is the square root of 4 times the square root of 7. Square root of 4 is 2. And then I still have this 7. The s to the third power, remember 2 can divide into that one time, so I'm going to bring 1s out. And I'm left with 1s underneath. Now, do you see we have a radical with a 7s underneath, and we have a radical with a 7s underneath here? Since they both are radicals, I can divide these. So I don't, it doesn't matter what the variable is. I know they are going to divide out, so they're gone. Now, these are your whole numbers that are left. They're on the outside without radicals, so they can also divide if possible, and they are. This 2 can go into 8 4 times. All right, so really, if I take a look at what we have left here, I have a 4 left on top from that 8. Down on the bottom, I still have that s, and we are finished. So if somebody said, hey, s is 4, I could stick 4 in here, do the math and get it all done, or I can simply take 4 divided by 4 and get 1, or I could put 4 in here and also get the answer 1, just this is a whole lot more simplified down. All right, and since this s is not underneath a radical down here, I don't need to worry about it. We followed all the rules. That's your finished answer. All right, I will put the homework on Google Classroom. Good luck, and let me know if you have any questions.